All right, so in the previous lectures, we had talked about lexical analysis and syntax analysis. And then we have two parts left for our translation stages, that is code generation and code optimization. Now, before we kind of go ahead and continue with code optimization and code generation, we need to first understand that in code generation, basically by just the name, okay, we're going to study it in a little bit more detail a bit later, but by just the naming convention, we can understand that we're just talking about generating the code, all right, like generating a machine-based code that the processor of the computer can understand. It could be a low-level assembly language for the CPU, like an IBM 1500 or something like that, or it could be just straight on binary. Now, while that is happening, computers do need to go ahead and evaluate um, kind of mathematical operations, all right? So like plus, minus, addition, subtraction. So we're just going to be talking about addition, subtraction, just so that we can simplify our calculations in like for the syllabus, right? So we just need to understand that how computers need to do it. Now, in general, mathematics follows the rules of BODMAS. Brackets, order exponent, division, multiplication, addition, and subtraction. Now, in our syllabus, we do not worry about exponents at the moment. We only worry about division, multiplication, addition, subtraction, and brackets. So computers need a way so that they can at least understand this rule or avoid this rule entirely. So what we do is we developed a notation, a specific way of writing mathematical operations so that computers can entirely ignore the BODMAS rule, and computers don't need to go ahead and worry about following these sort of significant rules to go ahead and perform calculations. This makes it simpler. It makes it easier to store these values and calculate these values, and computers don't need to follow the rules of operation. That means it doesn't need extra space. A programming language does not need extra space, extra syntax diagrams, extra Backus nor forms to store these mathematical rules. And this set of like this method of writing it is known as reverse Polish notations, or the RPN for short. All right, reverse Polish notations, or RPNs. So we're going to be learning how to go ahead and perform calculations with RPN, and we're going to be learning how to go ahead and convert uh normal the ones that we actually understand, the normal ones, from the normal form to the reverse Polish notation form. Now, mathematics that follow the order of operation rule are known as infix forms, okay? Okay, infix forms. So just like we have reverse Polish notation, the form that we follow is known as infix, I-N-F-I-X, infix. So the questions will be like, let's say you've got a mathematical expression, and with a mathematical expression will be given in infix forms, and you might be told to convert it into RPNs, or something that might be given in RPN, you might need to convert it to infix forms. So let's go and first learn the conversion. So we want to confirm infix to RPNs. Infix to RPNs. Let's say we've got the following mathematical notation: P plus Q multiplied by P minus Q. By the way, this is a question that is taken from May-June 2017, 9608. Okay, infix to RPN. So you want to go ahead and convert this form to from the infix form to the RPN form, the reverse Polish notation form. So before we go ahead and convert this, let's go ahead and learn some rules for infix to RPN. To convert from infix to RPN, we first identify operations like A and B. We identify operations. Identify operations, and these operations are written as A, B multiplied. So this is infix, and this is your RPN, okay? A, B multiplied. If it's given in a form like A times B in a bracket, we can remove the bracket, but we do keep the bracket so that we can simplify the calculation. In our final answer for a bigger expression, we do not use brackets in RPN. All right? And finally, initially follow the BOD-MAS rules, meaning you'll first convert division or multiplication to RPN, and then addition to subtraction to RPN. And this is the rule. First division, then addition or subtraction. So applying rules to the following, let's go ahead and have a look at this particular expression. So first, we go ahead and identify and use the BOD-MS rules. So the BOD-MS rules first tells us to look at the brackets. Remember, in our syllabus, we only worry about brackets and the normal operators. We don't worry about exponents. That's not part of the syllabus. So you first go ahead and recognize the brackets, all right? So the brackets have an operation of the plus or an addition operation. So we go ahead and first identify operations within the bracket, and then write it as PQ, positive, and we keep the bracket. And then we've got another operation and another bracket. In this case, we just follow the brackets first. In this case, we just follow the brackets first, and we identify the operations inside the bracket and keep it the same way. So we've got P, let's change it to blue. PQ minus. We write it in this format. And then between these two are multiplication. So consider this to be an A, consider this to be a B. So it's like A multiplied by B in mathematics. All right, consider this the following way. If that's the case, this can be ultimately written as PQ. Remember, remove all the brackets. PQ plus, PQ minus, no brackets, and then we put this symbol. And finally, that's going to be your RPN notation. All right, so that's going to be your RPN notation. Let's go ahead and do another RPN. Consider the following. Okay, yeah. Consider the following expression. Plus Q times M minus R minus P. Now, those who might have taken mathematics in AS and A2 levels or ever in your life, you might have noticed that I'm using all first brackets in this case. If in mathematics, this would have been written something like this with second brackets. Remember, in computer science, we don't use this convention for operations and operators. Like, it's pretty program language specific, so yeah, just don't use it. All right. So how can we go ahead and convert this method to RPN? Again, our first task is going to be identifying operators and stuff inside the bracket. So now notice that this part has two brackets. You can go ahead and work on each brackets the way you want because the brackets don't usually have an order. So let's go and work on this very inner bracket first because we can see an operator over here. So let's simplify this to PQ positive times M minus. Okay, interesting. So I've also noticed another operator here. So let's go and work on this bracket first. RP minus. Followed by, let's go and work on this bracket because we're still inside brackets, right? You can go ahead and remove the bracket you want, but you can keep it until your final answer so that you're like you can be sure. Or you could go ahead and just put a label under it as like a B or an A or stuff like that. All right, so now let's go and work on this bracket. So this larger bracket. So we've got another whole operator. Just consider this as like an A or an X. Okay, this is like an entire number because this evaluates to P plus Q, right? This evaluates to P plus Q. So it's going to be a single value. So consider this like an A or a B, like a single value multiplied by M. So this time, this is our operator, right? This is our operator. So we go ahead and write PQ plus M multiplied. Okay, no brackets. Remember, no brackets. Minus RP negative. And with all that being said, finally, this is our last operator, right? This is our last operator. So this is going to be my final answer with 2 negatives. All right. Again, this is my final answer. Right. So this is my final answer. So this is a method you can go ahead and convert from RPN to infix. Now let's go and take a look at the next case. Infix to RPN. Infix to RPN. So my first rule is identify operators. Identify operators. Next thing is going to be use substitutions. And finally, arrange using BOD-MAS. Now at this point, you might be wondering that, okay, we do need BOD-MAS rules in order to go ahead and understand how like RPNs work. Oh, I actually wrote the title wrong. This is going to be the opposite. So it's going to be RPN to infix. Okay. You might be wondering that you do still need BOD-MAS to understand, but once we learn how the computer actually solves an expression like this, it's going to be pretty clear to you that why we do it. So now let's go ahead and take this infix expression. Okay, let's go ahead and take an infix expression. All right, let's go ahead and take the infix expression that we just derived. Okay, this infix expression. Let's go ahead and take PQ plus M star RP minus minus. So our first task is to look at it from left to right, right? So from left to right. And this is the first operator we found because we know that AB star in infix means A times B. AB plus from in the RPN form means A plus B in infix. AB this, the slash symbol means A divided by B in the RPN form. Okay, so these are the rules. Same goes for subtraction. It's A minus B. So PQ plus in this case is going to be meaning P plus Q. So what we want to do is once we highlight this region, we write P plus Q is going to be equal to A. So we substitute this. So A M star RP minus minus. Now, again, we're going to be going ahead and following the rule and going from left to right. And we discover this expression again. AM star. So what we do is we again use substitution. Let B be A times M, because this RPN form can be written to the infix form in this manner. Once that is done, we go ahead and again substitute the values. B, R, P, minus, minus. And once again, we're going to be going from left to right. This time you're noticing that if we go from left to right, this right here could be the operator expression. So we use, let C be R minus P, and we then substitute it. So B, C, minus. Again, follow the rules, and then this entire thing pretty much becomes the operator. So what we go ahead and do is write B minus C. Now let's go ahead and open the brackets. B is A times M. Okay, now you can follow BOD-MS. C is R minus P. And finally, what is A, which is P plus Q. So A is P plus Q. Remember, always use first brackets, M minus R minus P. Now notice that once we get this expression, this is the exact same that we converted it, right? So this was our initial expression right here. This and this are the exact same thing. So this is how you can go ahead and convert from an infix form, from an RPN form to an infix form. Okay, our last thing is something that we are given mostly in the question paper. All right, so you might be given an RPN expression, and then you might be asked to evaluate an infix. You might be asked to evaluate its value. Now, there are two ways to do it. One is how the computer does it, and one is if you are given an RPN expression, you can first convert it to an infix expression and then do the mathematics normally like a human would do. But in this case, we need to learn both the methods. Now, you already know that how to convert a RPN. So right here is a RPN to an infix form. This is a pretty lengthier method, but once we kind of get used to this method that I'm going to show you, you can actually use either method. But one of them actually involves you to kind of draw some stacks, all right? Draw some arrays, draw some stacks. All right. So let me go and bring out the question. All right, so the question's out. So this is a question taken from a past paper. This is how it will look. So right now, this right here, we just evaluated this in the beginning of the lectures. Remember? If I can find it actually. Yeah, there you go. So right here, we just evaluated this. So I won't probably solve it anymore, but let's just go ahead and solve the past paper. But what we really need to understand is this part of the question. Okay, this part specifically is how an infix is converted. Now, if I do go ahead and go to the top of the question, we do have values of M right over here. All right, we do have values of M, P, Q, and R. So what I want to do is first, I want to go ahead and copy these down. So P is 4, Q is 2, R is 1, M is 10. All right. So the computer is going to be using stacks, all right? So you can see these stacks that's going to be given to you during your exam, all right? So let's go and first read the question before we can kind of start to evaluate and assess what's happening. All right. So it says the interpreter is executing Duriet's program. Now, a person named Duriet at the beginning of the question was actually making a program. The expressions are in infix form. The interpreter converts the infix to RPN. The RPN expression for Y is given. So sometimes you might be given a infix expression, you might need to convert it to an RPN and then use a stack to kind of calculate it. Other times they're just going to be giving you an RPN expression and the values in that RPN expression for the variables and ask you to calculate. So the rules in this case, if we start from left to right once again. All right, so we start with the first value, M, which is 10, and we keep putting him in stacks. The next value is Q. So once you come across Q, we go ahead and put it in stacks. So the first value was 10. Second, we go ahead and push the value of q, which is 2, into the stack. Then we come across an operator, which is the division operator. When you come across a division operator, so this is this basically means m by q, which means 10 by 2. So always in an RPN form, this is going to be the lower value. So lower value divided by upper value. So this is my lower value. This is my upper value. Not bound, sorry, the upper value. The value at the bottom divided by the value at the top. And you are never going to be encountering a decimal number, at least in the Cambridge syllabus. So if you're getting a decimal number, if you're trying to divide something, that means you probably might have done something wrong. So 10 divided by 2 is going to give 5. So what's going to happen is my value is going to change. So let's just erase this. So this becomes 5. 10 divided by 2, 5. It takes on the next value. All right, then next we take a look at the value of p. After this is done, p. So we go ahead and push p into it. So p, there you go, 4. And then we've got q. So we go ahead and push q to the stack. So it's going to be 5, 4, 2. And then we got an operator. So this operator means p plus q. So this value was p, this value was q. So what we go ahead is we take the top two values. We ignore the bottom value, okay? We take the top two values. That's the rule. So once you come across something like that, by the definition of the rules, we only take a look at the top two values, okay? These two values. So we are going to be doing 4 plus 2. So we're going to, 5 is going to remain as it is. 4 plus 2 is going to be 6. Then we have R in our system, all right? R in the RPN notation. All right, so I forgot to take the value of R, so I'm just going to have a look. R is equal to 1. So the value of R is 1. So we go ahead and see 5, 6, R. We push R into the stack. All right. Then we have got an operator. Again, by the definition of the rules, we're going to be taking a look at these top two digits, the ones that I'm highlighting. So that's going to be 5. Then we've got a negative. Now, when we have a negative, again, it's the bottom value minus the top value, or the lower value minus the upper value, not the upper minus lower, because this basically is going to be meaning that when you have got an R minus, let's say this expression is A minus R. So A was 6 minus R. R was 1. That's the logic behind it. So 6 minus 1 is, again, going to be another 5. Then we have another operator. So this operator is a multiplication operator. So by definition of rules, again, the next upper two. So that's basically the last two values in the stack, and that's going to be 25. That's your final answer. So use the variables and constant given in the program, okay? Changing constant interpreter gives the expression for y. So the value of y is going to be 25. So you see, the computer didn't need to follow any BODMAS rules. The only thing the computer needs to do is keep pushing stuff into the stack and then follow only one rule, left to right. That's what all programming languages do, left to right. That's it. The computer needs to follow only one rule. So now the thing is, if you have got an RPN expression and you want to go ahead and convert it to an infix expression, you can use a stack method to do it. In that case, you need to kind of visualize and draw a few stacks. How are you going to do it? It's actually pretty easy. So I'm just going to go ahead and, just for the sake of it, okay, but hopefully by now everyone knows that how you can go ahead and evaluate stuff from a stack by using stack. All right. Let's assume this 10 isn't there. All right, so let's say this 10 isn't here. All right, so now what you're going to be doing is we are going to be going just like the computer, okay? We keep pushing values into the stack. The first value is m. The next value is m by q, m and q. The next is a division operator. So this division means m divided by q, right? M divided by q. All right. So in this case, we have m divided by q in the new one. That's the new value that we are going to be pushing. Then we've got P. So M by Q, we've got P. Then we have got a Q. So it's going to be M by Q, P, Q. Then we've got the plus operator. And by the convention of the rules, these are the first two values. Look at the first top two values of the stack. So it's basically going to be M by Q plus, we can put a bracket in this case, P plus Q. Okay, P plus Q. And then we've got an operator R. So basically the stack contents are now M by Q, P plus Q, R. Right, R. And then we've got a negative sign. So R is going to be basically, so P plus Q minus R. Right? So if I've got a negative sign, P plus Q minus R. Let's close the bracket. Okay. From that, we are going to be doing multiplication. So it's basically going to be M by Q, P plus Q minus R. And finally, this multiplication means M by Q is multiplied to P plus Q minus R. Right? Because that multiplication operator, this operator right here, oops, I think you cannot see it. So this operator right here is going to be acting between these two. So this is the final one. Now let's go and plug in the values. M had a value of 10 divided by Q. Q had a value of 2 times. Let's zoom out a little bit so you can see the values. Sorry. P is going to have a value of 4 plus Q has a value of 2 minus R has a value of 1. So 10 divided by 2 is 5 times 4 plus 2 is 6 minus 1. 5 times 5 is 25. So we can see that we just arrived at the same answer just a while ago that we used with the stack. So it's pretty much actually up to you. If you want to go ahead and draw or visualize a stack in your mind, it's better to go ahead and roughly draw stacks if you're given questions like this, where you've got a okay, I didn't paste the question here, but the question could be like, let's say you were given a reverse Polish notation form, then you could kind of go ahead and visualize a few stacks in your mind or draw them roughly, and you can go ahead and perform your calculation. But I still find or prefer the method of choosing operators, okay, the method of choosing operators to convert from RPN to Infix. All right, so the last thing that you kind of need to remember are a few bullet points to this chapter. So let's go ahead and kind of study them. It basically follows all the conventions that we just learned. So first thing is why an RPN expression is used instead of infix by a computer. The reason is it provides an expression. This pretty much means that the expression is as it is. You really don't need to change that much on it. Easy to read from right, or as it is easy to read from left to right. Brackets are not needed for RPNs. Doesn't need to be followed. These are the few points or marking points that you need to remember to go ahead and kind of answer in the exam environment. And the last thing that you need to do is the use of a stack to evaluate a RPN expression. How are you going to do that? Pretty simple. The expression is worked from left to right. Make sure to write it in words. number, it is pushed if the element is an popped from the stack. You need to use the terminology of push and pop that you learned from your AS concept in order to go ahead and answer this for something to a stack. After pop operation, the operator's operation, that is, i.e., subtraction, multiplication, division, are performed. On the numbers. And finally, the result is pushed back. Pushed back until the last item is dealt with. So these are a few marking points that needs to be remembered for the exam scenario. All right, so in the next video, we're going to be working on the last two topics that is remaining.